Okay, so now you know how to go from moles to moles using a balanced chemical equation. Now it's very important to realize that the only time that we want to do this is when our question is giving us information about one substance and asking us information about a different substance. To be able to go from one thing to another, we have to use that mole ratio step. So, first thing I'm going to need is my balanced chemical equation. So I need my balanced chemical equation for aluminum metal with chlorine gas. So I'm going to have aluminum, which is a solid, reacting with chlorine, which is that diatomic, and it's a gas. And then my product is going to be aluminum chloride, and then I'm going to have to balance that. Okay, so now that I have my balanced chemical equation, I can go on to my second question. When 40.48 grams of aluminum is mixed with chlorine gas, how many grams of aluminum chloride are produced? So I'm starting with grams of aluminum, and I'm wanting to figure out grams of my aluminum chloride. So I'm going to start my train tracks with that given number, and again that's of aluminum. Before I can go from aluminum to aluminum chloride, I have to get that aluminum into moles. So I first have to go from grams to moles for aluminum. So to do that, if you don't remember, you're going to use the molar mass of aluminum. So if you look at your periodic table, the molar mass for aluminum is 26.98, and remember we round to the tenths, so we're going to use 27.0 grams of aluminum for 1 mole of aluminum. Now that I have that in moles, I can do my next step, which is that mole ratio step. So I'm going to look, if I have moles of aluminum on top, I have to have moles of aluminum on the bottom. And I'm trying to go to aluminum chloride, so I'm going to put moles of aluminum chloride on top. I'm going to use my coefficients from my balanced chemical equation to do that. That's where that ratio comes from. So in my balanced chemical equation, I have 2 moles of aluminum and 2 moles of aluminum chloride. My final step, because my question is asking for grams of aluminum chloride, I need to go from moles of aluminum chloride to grams of aluminum chloride. So moles of aluminum chloride on top. So I have to put moles of aluminum chloride on the bottom, and then I have to put the molar mass of aluminum chloride on the top. And the molar mass of aluminum chloride is 133.5 grams. And then you're going to do that calculation on your calculator. On your calculator you should be getting 200.15, and I want to make sure to give my answer in the right number of sig figs. So I look at my given number, that 40.48, that has 4 sig figs, so my final answer should have only 4 sig figs, so 200.2 grams of aluminum chloride is our answer. Alright, so next problem. How many grams of aluminum must react with 15 grams of chlorine? So now I'm going to start with that given number, that 15 grams of chlorine. Again, I have to get that to moles first, which the molar mass of chlorine is going to be 71. Once I get moles, I can use my mole ratio step between chlorine and aluminum, looking at those coefficients from our balanced chemical equation. And then once I have moles of aluminum, I want to get that to grams of aluminum. So moles of aluminum on the bottom with the molar mass of aluminum on top. Once you do that calculation, again we want to do sig figs, so 15.0 has 3 sig figs, so you should be getting 3.80 grams of aluminum. Alright, so our next problem, again we have to start by writing that balanced chemical equation. So bromine, which is diatomic, and a liquid, reacts with sodium iodide, which it says is aqueous. And again, what are my products going to be? Well, my products are going to be iodide by itself plus sodium bromide. And then I have to balance it using my coefficients. So I'm going to have to put a 2 in front of sodium bromide to balance my bromide, and then a 2 in front of sodium iodide, and then it is balanced and ready to go. Alright, so if I look at my question, how many grams of iodide will produce when 35.8 grams of bromine is reacting? So again, I'm going to start with that given number. First step every single time is to get that to moles. So I need the molar mass of bromine, which is 159.8. Once I have moles, then I use my mole ratio from my balanced chemical equation between bromine and iodide, and it's 1:1. And then our last step is to get to grams of that iodine. So again, I need the molar mass of iodine, which is 253.8. On your calculator, you should be getting 56.858. Again, we want to have the right number of sig figs, so 3 sig figs, so 56.9 grams of iodide would be your final answer. Alright, our last problem. How many grams of iodine will be produced when 1.25 grams of sodium iodide reacts with excess bromine? Again, we are using that balanced chemical equation that we just got done writing. You're going to start with the given, which is 1.25 grams of sodium iodide. First step every time is to get that to moles, so I have to figure out the molar mass of sodium iodide, which is 149.9 grams in 1 mole. Then I'm going to look at my balanced chemical equation to get my mole ratio between sodium iodide and iodide. Oops. And then I'm going to get that back to grams by using the molar mass of iodide. And on your calculator, we want 3 sig figs, so 1.06 grams of iodide is what you should be getting. Now, hopefully we've noticed a pattern. There are some steps that you will be doing every single time on these calculations. We always want to start by going from grams to moles, then our mole ratio to go to moles of our other back to grams. Your homework, half of it you're doing just mole to mole ratios, the other half you're doing grams to mole ratios, or excuse me, grams to grams ratios. These are going to be, your homework is going to be due Monday. Go back to this video, go back to the other video, go back to the video going over the homework just in case you weren't understanding that, and you should be good to go.